This is 8.1, sequences and summation notation. So we're going to touch just the surface of sequences and summation, but the definition in this section for a sequence is a function with domain of natural numbers. It's basically a set of numbers that go in a particular order. So, and typically they could be, arithmetic sequences, geometric sequences, recursive. So there's different types of sequences that we're referring to, but in this section, we're specifically only interested in the set of domain with the natural numbers. So here's some examples: 2, 4, 6, 8, and then dot, dot, dot. So obviously you need to figure out the pattern, and then, then from there you can guess like the next number, the next number, the next number. Or what if I wanted to find the 100th term in the sequence? And let's look at the next example. 0, 3, 8, 15, 24, blank, blank, blank. So what would be the next number? The next number after that, the 100th number. And then the last number, we have 1/2, 2/3, 3/4, 4/5, 5/6, and then dot, dot, dot. So what would be the next number, or what would be the 100th number? So let's answer these questions first of all. So first of all, when you look at a pattern, you have to notice, what is the pattern to be able to get to the next number? Well, here I notice this is I'm adding 2. I'm adding 2. I'm adding 2. So notice it has to be the same pattern going from one number to the next. So, and it is, I'm adding 2 on this one. So literally I have 2, 4, 6, 8. So if I wanted to find the next number, it would be 10, and then 12, and then 14, and then so forth. So, and then what if I wanted to find the 100th number or the 500th number? Well, I don't want to keep adding 2. That's not what I want to do. And so what I want to try to do is to find a function that represents, 2, 4, 6, 8. And then what we're going to do is then I can use that function to find the 100th term or the 500th term to be able to do that. So again, notice the first term in the sequence. So this is my first term right here. And then this is my second term, and then my third term, my fourth term in the sequence. So think of this as A1, A sub 1, and A sub 2, and A sub 3, and A sub 4. And those are my different terms in the sequence. And so notice, how can I write this in a, if I'm thinking of the first term and it's 2, so what I have here is a sequence that literally is 2n. So whatever the first term is, so this is literally my sequence, and think of it, the first term. So think of the first term, that would be, you plug 1 in, and so that's where I get 2. And then my second term, I'm going to plug 2 in, and that's where I got 4. And then my third term. And so notice this little sequence will tell me, if I wanted to find the 100th term, I just need to substitute 100 into there, or the 500th term. So A500, the 500th term, you just literally need to do 2 times 500, and then you can get 1,000. So you don't have to sit here and add 2, add 2, add 2, add 2 500 times. What you do have to do is just find out the function for that. So let's look at the next one. So the next one says 0, 3, 8, 15, 24. And again, there are different types of functions. Some of you might look at this and say, well, notice here I'm, for the first term it's 0, second term I'm adding 3. Then the next term I'm adding 5. Then the next term I'm adding 7. And then the next term I'm adding 9. Oh, well, that's an easy sequence. I'll just, the next one I'm going to add 11. And so to find the next term, if I only ask you to find the next term, then you can just say the next term is 35. And that's true. You can do that. But what if I ask you to find the 100th term or the 500th term? So what we want to do is find a function that represents this. And again, keep in mind, this is A1, this is A2, this is A3, A4. So you'll have to come up with a sequence that represents this. And notice notice the first term, this is A1. So think of, how can 1 go to 0? And then how can 2 go to 3? How can 3 go to 8? And so you start noticing a pattern. Well, wait a minute, 1, and the first term is 1. The first is 1, then the second, and then the third. That's the first term, second term, third term. And notice let's just say specifically when I get to the third term, I notice 3 squared is 9, but this third number is 1 less than that. Oh, and then 2 squared is 4, but see the second number is 1 less than that. And so you could literally do this same, you could come up with your function, an equals n squared minus 1. And so you could literally, the fourth term, so you could literally plug 4 into there. 4 squared is 16. 16 minus 1 is 15. And then the fifth term, 5 squared is 25. 25 minus 1 is 24. So if I ask you to find the 500 term, you can literally find it now once you come up with the function. All right, so let's look at this last one. So if you look at this example here, I have 1/2, 2/3, 3/4, 4/5. So it looks like if you just look at a pattern, you might say, oh, it's kind of counting. So 1, 2, then 2 goes here, then 3, and then 3 goes up here, then 4, then 4 goes up here, 5. So you might notice a little pattern like that, and then that might help you find the next number, or the next number. But what if I ask you to find the 100th term or the 500th term? And so that's what we want to do, is we want to come up with some function that's going to relate to that. Well, again, notice that the first term is, I have here the first term. The first term is 1. I mean, this is the first term, this is the second term, this is the third term, this is the fourth term, this is the fifth term. And notice the tops, the numerators, are exactly that. So I know n, and then notice on the bottom, it's 1 more than that. So n plus 1. So the function is this right here. So you kind of just have to notice, compare it to the first number, the second number, the third number, and then notice what the function is. So once I have the function written in general form, then I can literally find the 100th term or the 500th term by simply just plugging those numbers into that function. And that's sequences. So let's look at sigma notation. Now, sigma is a Greek alphabet, and it looks like a funny looking E, sort of, capital E, and it just means sum. And so it literally represents the sum of something. So let's look at how to write this in general form. So here you have sigma notation. And notice at the bottom, it's k equals 1. That's my starting. That's what I'm going to start at. And it goes all the way to n. So a sub k literally would be a sub 1, because it's starting at 1. And then it keeps counting a2, a3, and it keeps going all the way to a sub n, because it stops right there. So here's an example here. Sigma, it starts at 1, and then it goes all the way to 5. So, and again, it's the summation of that. So you literally have, if you want to write it this way, so you're literally going to start at 1, then 2, then 3, then 4, and then 5. And so that's literally going from 1 to 5, and then you're going to find the summation of that. All right, so that's my first example. Let's look at a couple more examples. And again, this is just the basic scratching the surface of sigma notation summations. So here I have the summation of x equals 3. Again, notice the starting position. I want to make sure you pay attention to that, and the ending position. So literally this is, you're starting at 3, and then you're adding it to 4, and then you're adding it to 5. So you go from 3 to 5, and it's just plain x. So you're just going to find the summation of that, and you're going to get 12. So here the starting position, the ending position. So you're going to start at 5, then 6, then 7, then 8, then 9, then 10. And again, some questions may ask you to actually find the sum of that. Well, that's what that is. Or the directions may say just write out the summation. And if that's what the directions are, then I'm done. I don't really have to add those to be able to do that. So I think you get 55 here again. So 11, 20, 30, 45. And then the last two examples, I want you to notice I have the it almost looks identical, but I want you to pay attention to what it's actually saying here. And I wrote this on purpose because they both start at 2, they both end at 6, but notice how it's written. And I want you to pay attention to those because it makes all the difference in the world. So, you know, this literally, the first one says 2, and then x squared, and notice you're going to put a 2 in there because it starts at 2. And then 2, 3, 2, 4, 2, 5, and then 2, 6. And then I want you to notice, and then we would have to calculate that. The next one, I want you to notice what it says. It says 2, and then you're multiplying it by the first number, and then you're going to square it. 2 times 3, then you're going to square it. 2 times 4. Oops. All right, and then you'd have to calculate. But again, I want you to notice the difference between where the parentheses are. The parentheses is on the second one, and then notice the first one. We're going to get different answers here, so just pay attention to how you would write that out. And then again, if it asks you for the actual summation of that, then you would calculate each one of those. And then again, the first one you get 800, the second one you get 1600, and again, that's the difference between those summations.